Thank you, everyone, and welcome once again for another edition of the Climate Connections Build Edition. So today we have really great, amazing speakers. But before we move forward, I would like to go on the next slide, please. Yeah. With gratitude and respect, we want to acknowledge the lands on which Foresight operates, and the traditional, ancestral, and unceded territories of the First Nation Inuit, as well as the Métis people as well. So we just wanted to acknowledge that and welcome to this session, and we look forward to an exciting session. Next. Yeah, so today's agenda, we're just going to have a little bit of welcome and introduction, basically with the speakers. We will go a little bit more in the industry expert panels and question and answer sessions, where we will have to go through that. And then we'll have a breakout sessions around 12, around noon, and then we'll have our closing remarks as well. So we would just like to welcome our speakers and to do a brief introduction. The next. So our goal on this program is to accelerate the transition we need to rapidly launch and commercialize. So Foresight's role is our goal is to make Canada the first G7 country to reach net zero. And this is why we're trying to use our Helix 5s to bring investors, innovators, academia, and the different industries to work relentlessly in empowering and driving clean tech innovation in Canada. And Foresight is at the forefront, and that's why we're having these sessions today, working on with amazing speakers from industry that will share their problems that we have, that they have, and with some researchers that are around within today as well, to ask questions and get more clarification from the issues that are presented here today. Okay, next. All right. So at Foresight, what we do is we do have acceleration programming, we have innovation challenges, we do this through capital attractions as well, export development, as well as ecosystem building. So these are the key different pillars in which Foresight operates. We do have different programs within Foresight under this. We have the next streams, we have the acceleration programming, we have the challenges, we have research, the research team as well. So these are all different programs within Foresight, but are all working in these two different couple of pillars in helping advance the ecosystem as well as export development, and in the investment, our investment readiness program that helps investors and ventures connect within the ecosystem. All right. So today's panelists, we have Brad, who is the president of ES Consulting. We have Niklas as well, who is the senior innovation management and mobility. And Jamie, I'm not sure he's already joined us already, but Jamie is the senior vice president from QuadReal Property Group, and they will be sharing their problem statements and basically pitching to you, doing a reverse pitch of their challenges that they face within their industries and sectors, and we'll hope to have an interactive session. So I would like to welcome Brad to just give a brief introduction about himself, and then we can go around the table with the speakers to introduce themselves, and then we can go through the session properly.
Great. Do you want me to throw my challenge out as well now, or save that?
Yes, you can throw off your challenge for now, but basically just introduce yourself, where you're from, like a little bit about your background, and then we can move on to the next session. Yeah.
Fantastic. All right. Hello, everyone. My name is Brad White. I'm with SES Consulting. So SES Consulting is a sort of a small, medium-sized consulting firm. We're based in Vancouver. We're about, I don't know, 15 to 20 people, depending on sort of when how you count staff. But and our expertise focuses on existing buildings, and historically our work was mostly around energy efficiency. That has evolved, I would say, over the last 5 years into now a number of projects, and I would say sort of the majority of our projects are now focused on building decarbonization and greenhouse gas reduction. So we've seen a real market shift over the last few years. So we are engaged in every part of that process, from sort of helping owners identify at a high level what their opportunities are, conducting detailed energy studies, audits, helping them apply for funding, and then right through to doing detailed design, overseeing construction process, commissioning, M&V, ongoing monitoring. So with all that, we are getting a really good sense of what a lot of the challenges are as the industry starts to make this shift towards decarbonization. And I should add that our focus is mostly on larger buildings, so commercial, office, retail, government buildings, university buildings, apartment buildings, condos, that sort of thing. Yeah. And so do you want me to share my pitch now, Azu?
Yeah, no, maybe you can wait when we're done with the introduction and you can.
Sure. Yeah, I'll do that. So I think, yeah, that's good. I think that's good for me for an introduction, I think.
All right. Niklas.
Yeah. Good day, everyone. Thanks for inviting me. Looks like an awesome crowd and looking forward to discussions. I'm the Senior Manager, Innovation Management and New Mobility, long title in Translink. Basically, what I'm doing is running our innovation team for the enterprise. And for those of you who live here or perhaps already familiar with Translink, big, I was going to say small and medium-sized transit agency, but we're quite big even in North America. And one reason for that is that we are not only running the trains and buses and ferries and all that, but what is perhaps less known is that we're also helping to really manage the regional transportation system for Metro Vancouver. And we have ambitions to become even more multimodal, I guess, with our ferries and buses. And we're already multimodal, but I think the coordination with partners in this region, Metro Vancouver, on a number of things, including implications of land use and major developments and major highway infrastructure and all that. We have authority around how we use our roads and all that is maybe less known. So we are basically a major infrastructure owner and operator, as well as as running these vehicles and buses and all that. So as part of the infrastructure part, of course, we are acquiring or constructing or maintaining and a number of assets, and I think we have some 20 billion Canadian dollars lined up now for investments down the road. And not only the big project you read about, such as the gondola to SFU and Patula Bridge and SkyTrain out to UBC and all that, but it's also to extend the reach and coverage through rapid buses is a big thing we do now, and really kind of creating these arteries around the whole region to have an equitable kind of access to opportunities for everyone. Paratransit and whatnot is also under our, but I think one final major thing is that we are for sure having quite aggressive climate action goals. The most tangible is the electrification of our whole bus fleet with quick move on that, but we are in help and need to also look into other areas, and I will kind of, my challenge later will be exemplifying that. So yeah, nice to meet you all, and hope we get some good comments.
Thank you so much. We'll hand it over to Jeremy.
Hi, I'm Jamie Great-Donald. I lead sustainability at QuadReal. We represent the pensioners, the public employee pensioners of BC. And so they invest through BCI. One of the asset classes at BCI is real estate. So we manage office, multi-residential, retail, industrial buildings, about half in Canada and half globally. So US, Europe, Asia predominantly. And we've set zero carbon targets, 2050 for everything, including all tenant emissions and all embodied carbon. And 2040 for our office managed office portfolio, and we've I think captured a lot of low-hanging fruit. We're about 40% reduction now on the operational carbon, and so really looking at what's next, and a lot of that involves innovation.
Awesome. Thank you so much. That's awesome. So I just wanted us to go back to Brad. Then we can explore the problem statements that you're having. So we just want to make sure you have about 3 to 5 minutes. So what is your problem that you're currently frequently facing within your industry?
All right. Well, there are many, but I'll focus on one. So in our role as the engineers and designers, one of the things, and I don't know, sort of make up the audience here, but the usual process of how engineers go about designing new equipment and for retrofits, it relies a lot on sort of rules of thumb, models of buildings, and there's sort of this built-in conservative streak to the engineering profession, where you try not to, you oversize your equipment, you make things a little bit bigger, a little bit stronger than they need to be, which is generally good practice. But when we're specifically talking about building heating systems, and I should say, when we're exploring decarbonization, especially here in BC, but it's true elsewhere in the country, we're talking about electrification. So in a lot of cases, we are talking about moving from gas-fired, oil-fired boilers to heat pumps, whether it be air source, ground source heat pumps. Air source is usually, especially if your climate isn't too extreme, usually the way to go. The challenge is heat pumps are a lot more expensive than boilers, almost an order of magnitude more expensive in some cases. If you look at the heat output you get from a boiler versus a heat pump. So the standard practice of engineers of oversizing equipment leads to a lot of issues. The most important being, it costs the owner a lot more money to put in this equipment if engineers continue to oversize things as much as they have in the past. And that may be enough just to kill the project. It may not go ahead because it simply doesn't make financial sense. So one of the things that we've explored in our practice is to start to use actual building data in design decision. I'll give you a really simple example of this. We're doing a new domestic hot water system for a building. So this is, the hot water used for showers, sinks, that sort of thing. The building had 2 existing 600,000 BTU boilers. This is a big apartment building, 2 pretty good sized boilers. We're retrofitting that system with a combination of heat pumps, boilers for backup, some electric heaters, other things. But there was a period of time where we had to really just run on the boilers. And what we found, and we actually metered the hot water usage in the building ahead of time. So we actually knew what the real consumption was. And what we found is that it was about a third of what the handbook values would tell you. So typical engineering practice was you look up the values, you have this many apartments, this many 1-bedroom, this many 2-bedroom, you get a standard peak load, you size based on that. But when we actually metered it, the real data was about a third of what the handbook values would tell you. And we actually successfully ran the building for quite a while on 2 200,000 BTU boilers instead of 2 600,000 BTU boilers. So just a really simple example of where, the standard practice would have been grossly oversized. And I can give you a lot of examples of this. So we're pulling data out of, meters, building automation systems. So we can do the same thing on the heating side. We can look at what the building automation system the building has for all the heating cooling loads and actually use that to size. So my challenge is, though, as an engineer, I don't have any tools to do that other than Microsoft Excel. So I'm literally pulling CSV values out of the building automation system, putting that into Microsoft Excel, trying to do charts, trying to interpret that to be size equipment. That takes a lot of time. And quite frankly, it's pretty clunky and cumbersome. So my challenge is, and I'm also not a data scientist. I mean, we're doing very basic data analysis. And so my challenge as an engineer is I'm looking for better tools to be able to effectively use real building data, real building performance data, whether that be sourced from meters or building automation system, to do effective low carbon heating system design.
Yeah, so
maybe I'll stop there. I can add more if needed, but
Yeah, so I can also have if there's anyone who has specific questions for him in terms of the problems, please feel free to put it on the chat, and Nisa will share that with us as well. So I just wanted to ask, in terms of the problems, you've mentioned like how frequently, what are you currently using apart from Excel sheets? Is that what you're already using right now to solve the problem, or do you have other tools that you have tested out but they're not a perfect fit?
Well, we still use the standard engineering tools where you plug in, this is what the envelope is, this is what the exposure is, and it gives you like heating and cooling loads. And we'll cross-reference that against what Excel tells us to try to come up with an end result that we feel is reasonable. But even that is kind of a cumbersome process. And I just think and all of that is fine for new construction where every little detail about the building. But I'm specifically focusing on the retrofit market where, you might have a 50-year-old building. We have, we're lucky if we have drawings. If we do, they're probably out of date. We may not have all of that sort of standard modeling information, even if I wanted to use it, which I don't. But so we're missing all of that. But on the other hand, I do have often real performance data out of the building automation system. Most large buildings now have fairly modern building automation systems that I can extract data from. And there's lots of data analysis tools out there, but most of them are geared towards operations. There's lots of fault detection software, things like that, but they're geared towards operations, helping operators operate the building more efficiently, flagging operations problems. They're not geared towards the design community. And so as a designer of low carbon heating systems, there's a real gap in tools that can help us do our job better. And that would help build capacity and accelerate the pace of retrofits, which is something that is sorely needed.
Brad, if I may, Lou, can I?
Yes.
Okay, so here is, and my name is Denarin Berrio, and I'm the president of DBPS Consulting Inc. Now, here is a situation that you encounter, and many buildings designers encounter the same situation. You're looking for information, or the information that you have on hand is, let's say in the case of boiler manufacturers, those boilers information that you have on hand is boiler data that comes from lab tests. And that information is usually done under specific parameters. And basically for condensing boilers, for example, you have a high delta T of, let's say, 52 degrees Celsius, water in, let's say, 60 degrees Celsius, water out, 26 degrees Celsius, out 82 degrees Celsius. Those are the conditions that are specifically for particular condensing boilers to get that max output. But in reality, what I see you getting is a low delta T when you look at the boilers that you actually have in your building. Now, this is very common situation that we have encountered, and we develop a concept we call zero mixing that counteract that situation that you find in the field. Now, since if you keep doing what you're doing, you're not going to change from the conventional situation what involves what we call mixing operation from the actual test conditions that are very different, because when you're testing a condensing boiler, mixing operation doesn't come into picture. Now, mixing operation have to do with boilers pumping hot water into the system and colder water from the system coming back to the boiler and mixing in the hydronic system. That's what caused that problem. Now, most of the HVAC system today, including HVAC, CHPs, solar thermal, you name it, have the same situation. They are designed with information that is based on lab tests, not actual operation. Now, if you look at your system, something that you're going to notice right away is that the delta T between the water that is coming to your boilers and the temperature that is going out of your boiler is about 10 degrees Celsius, and it could be less than that. And that's what is causing that limitation on your boiler output. Now, the way it could be solved, and I'm sorry, it's just an opportunity for me to pitch DBPS technology, zero mixing tech, which by the way is patented here in Canada and the US, is you gotta move away from conventional way you're designing and get more into a zero mixing where you have those high delta T's, and we have a way to make that system to be more efficient. Once you fix your mixing problem, many of the things that you have just mentioned going to go away, no matter what system you have. Like I said, heat pumps, condensing boilers, solar thermal, CHPs. So that's and I could give more details about the technology. It's not the moment, but there is something that we can do for you if that's the case. If you're encountering is what you see everywhere. So.
Thank you so much for that intervention. I think I'll just pass the to Niklas to go through the problem, and Brad will get back to you after this first round.
Okay. Yeah, thanks very much. And as being a non-engineer, I'm learning a lot in this call always. So I started to say that we have a climate emergency. We all know that. We also know that, you know, we have some 35-ish% of GHG emissions in this region coming from transportation. Of course, you know, including personal, commercial, and transit and all that, but transit's also for sure. So our low-hanging fruit, so to speak, to reach our zero emissions, net zero GHG emissions by 2050 is through electrification. So we are aggressively electrifying our bus fleet, our diesel buses. Of course, we already transitioned to green diesel and all that on where we can. We have the largest trolley electric bus fleet and so on. So we have done a lot, and we can do more. Now, having said that, that is a separate kind of separate problem. It's just a bit hard for independent innovators to get into, because we have the big OEMs like Nova Bus and the bus OEMs to taking a lead in R&D and all that, and it's pretty complex systems. But we have a lot of other areas, and like we heard before, I could name easily 10 challenges we have, but I picked one, and it's around the effects of the climate emergency more, because we're already seeing last year's increasing impact of climate change and on our operations. So, you know, such as extreme weather events and heat waves and, you know, wildfire smoke and all this, right? Intense rain and it's really here, and it's intensifying, and it's affecting our and disrupting our operations. So my challenge I had was around how to enhance the resiliency around our transportation system, especially, of course, public transit, due to the impacts of these events and the climate change. I know it's a big ask. Resilience is a big area, so I asked my team to sit down, give some examples. Actually, I can name a few and see if anything resonates, but just to give you some flesh on the bones. So like I said, extreme weather events, I can see that we would really benefit from having more green roofs, having better material in our pavements and all that can actually absorb and manage storm water runoff. I can see the risk of flooding. We've seen it last years is really damaging our transit facilities and the communities, of course. But on the digital side, an area such as adaptive traffic management systems, using real-time data on traffic and weather, and really optimizing traffic flow and not only reducing congestion, but really improving safety during extreme weather events is another potential area. We have, of course, the whole resiliency in our facilities, in our transit facilities, which leads to kind of more common sense things, but such as new design features on when we renovate and invest in new facilities, high efficiency HVAC systems and passive solar heating and cooling and all, anything energy efficiency, including lighting and all that is I think we group it under improving our resiliency. Sensors, and I can see we have a lot of in common, perhaps with QuadReal and other running big facilities, but any kind of sensors and the back-end data analysis to prevent malfunctions and before they happen is extremely interesting also for the transit system. And then getting to, I guess, more innovative things such as microgrids, and I think part of the electrification we are so aggressively pursuing will also lead to some resiliency problems. So anything on the microgrid to kind of improve grid stability, reliability is going to be important. Also, backup solutions for the main power grid. I know that we in the coming years are going to electrify our fleet and add some 400 buses fairly soon at a faster pace than BC Hydro can deliver. So we're going to have to provide backup for outages and also look into more, perhaps even generating our own energy through solar panels, wind turbines, and heat pumps. Interesting for us as well, but also regenerative braking, and really try to optimize how we use the limited electricity we can get. And that's in a reality where we see electrification is happening not only in transit, obviously, but in personal transportation and cars. And we simply don't have enough juice in this region soon, so we're going to have to look into that. So these are just a few examples on the resiliency thinking we are actually working on a roadmap specifically on resiliency for next year. So I think this is very timely to get in your ideas. And then I will pass on to the next speaker or take any questions.
Brad, do you find using BIM, building info modeling, 3D CAD software like Revit with third-party plugins for calculating HVAC loads are too cumbersome, too time-consuming, and not agile enough for your needs?
Short answer, yes. I'd say, BIM is great if you've got a new building that was designed in using those standards, and you have those existing models. But as I said, our typical case is going into a 20, 30, 40-year-old office building. There are no BIM models. And yeah, to build one at that point would be extremely time consuming, extremely expensive, if you could even do it. Because there simply may be things about that building at that point that are unknowable without dismantling aspects of it. So generally, no, I don't consider it realistic to use a BIM approach. As I said, if you've got a new building and you have all that BIM data, then absolutely, I think that's certainly a viable path. For the vast majority of buildings that we're trying to retrofit, yeah, we simply don't have that information available, and yeah, to develop it for the purposes of a retrofit project would be far too cumbersome. And that's sort of my general. Some of you may be familiar with the term digital twin. It's sort of an evolution of the BIM concept where you create sort of this fully virtual model of a building. And again, that is fantastic if you have the data to be able to generate that model in a reasonable amount of time. But again, for most of our projects, no, we're not. So that's why I go towards the building automation system as a source of data, because it is there in most buildings and often has a lot of the data that we already need in it. It's just sort of getting that into a form that is useful for designers that is the challenge.
All right. Thank you, Brad, for that wonderful deliberation. So please, we'll just go back to Jamie. Jamie, if you just could give us your problem, what are the frequency of the problem, like what the problem you're looking for solutions, and just give us a brief of your reverse pitch, and then we can take it from there. Over to you.
Thank you. Appreciate the opportunity. So two brief problems. One, we're asking buildings to do a lot more with electricity, particularly electric vehicle charging, and as Brad mentioned, heating with electricity instead of natural gas. This can balloon electricity costs of the building, particularly where there's differences in time of use rates or kind of demand charges. And there's very little sophistication right now in how to help buildings with demand management. So figuring out what the utility price is, figuring out what demand charges are, and how to both optimize that and or send signals back to the chargers and other things. So that's one significant problem that we will increasingly face as we electrify. The next is how on the embodied carbon, so the carbon in the materials we use to build new buildings and to retrofit buildings. It's sort of a big ugly space, and how is there a way to focus on a smaller number of aspects and get the industry more broadly aligned with, hey, these are the ones to focus on. These are the smaller number of choices that you can make, because there are a lot of people, looking in every direction and spending a lot of money on complex assessments. And I think the options and answers aren't that complicated at the moment, but there's very little awareness of it. So 1 on the how to better manage electricity demand in buildings, and the second on the embodied carbon of materials in buildings. Thank you.
Thank you, Jamie. I just wanted to maybe just a little bit clarifying with electricity managing the problems you're mentioning. Is there any current solutions that you think might work, or why is the ones that already exist and not really working?
This is from Kelly. Almost need a database or likely values from different eras, regions for various assembly types or materials. A drop down to fill in blanks. I think that's for Brad again.
Might also be for, if it's referring to embodied carbon, it may be related to what Jamie put out, but yes.
If both of you can take a dive into that question.
Yeah, I mean, that would certainly be a help. I'll say you would still face a challenge in buildings of just knowing what is there. I mean, it would really help with approximations. But again, I come back to that the traditional design process makes a lot of assumptions about not only buildings made of, but what's in the building and how it operates. And I come back to the approach of using real building data cuts through a lot of that, because you don't have to make an assumption about what the loads in the building look like. You can actually extract that out of the performance data of the existing systems in the buildings. And yes, they may not be optimized, and that's part of it. So there's a whole thing there. But for the problem, so yeah, it certainly will help address aspects of what I'm referring to. And if nothing else, we give you a nice something to kind of cross-reference again. I'm big on cross-referencing multiple independent sources of information to sort of arrive at your best truth, because ultimately all sources of information are biased in some way and have some assumptions built into them. And if you can kind of take a couple of different approaches and get to a reasonably consistent answer, I think you're on the right track. So I think, sure, that's helpful. But doesn't necessarily address sort of the core of what I'm getting at, which is that I think we can bypass a lot of that traditional approach that does make assumptions about how buildings are built and operate.
Yeah. Jamie, you want what's your take in terms of the carbon embodiment?
Yeah, I think that's simpler. There's a drop-down menu. It's great. I think it's what are the largest sources of embodied carbon, and what are the 2 or 3 main choices, alternatives. I think just having that would help many people get to like 20 to 40% reductions, and then get alignment within the supply chains that a range of building owners are pushing for those items. Like it's too fractured at the moment, so simplifying it seems to be the key.
Okay, thank you so much. So we do have other questions on the chat, but just to go back to Niklas, so in terms of the building resiliences, do you see other organizations or other provinces having these similar problems? And how do you think, if you find a solution, how do you think that might be applicable to other provinces or other industry folks that you're working with?
Mm-hmm. Yeah, for sure. I found it surprising. I've now been 5 years, I guess, in public transit in Canada, and so kind of a bit new to transportation, public transit. I found the transit agencies surprisingly low level of communication in between each other. Everyone, of course, are facing their own geography and weather, whatnot, and their own challenges and opportunities and problems in each region. Translink, partially because what I opened with, having such a wide mandate to affect policy and work together, kind of have a convener role in this region, working closely with Vancouver Economic Commission to Metro Vancouver to any of the big organizations who are and kind of marrying together both balancing growth, economic growth with. We are in a bit unique position in North America, meaning that we are actually looking a lot to Europe and agencies such as Transport for London and others who have a bit of a same setup rather than the south of the border. But having said that, climate, of course, these problems are the same for every transit agency to various degrees, and we are trying to learn from all of them. But I think we can do way better to maybe get together in a consortia and fund R&D and also academic research and innovation in this area. So that's
All right. Thank you. I think I saw a couple of questions as well from Colin on the group. He's just asking a question for all of you. Do you believe in or hope that AI will be able to help with the predictive and automation challenges that your needs require? Like, could AI be the solution? It's for all the speakers. Niklas, Brad, you want to go first?
Sure. I see AI certainly having a role in building operations. It already is. There's, I can name half a dozen companies that are active in the market with kind of AI-based solutions that make claims around running buildings more efficiently, and some of them seem to actually do a fairly decent job of that. I haven't yet seen anything AI related that again would sort of aid the design community. And certainly there may be a role for AI in helping to interpret data. I think that could certainly be a solution, but there may also be sort of more traditional data analysis tools that could just be applied to a different market. That was said, I said that traditionally, I'd say the design community is lacking in any kind of tools that make use of large data sets. So anything would be better than what we have now. But sure, I mean, you could apply AI algorithms to help do analysis on large data sets to predict values. And I'd say one interesting aspect of it may be, and tying in with the resilience piece that's been discussed, is to look ahead. So we'll have data from existing climate that the buildings have experienced. Interesting maybe to apply different climate scenarios to that data and see how it shifts. And that may allow us to predict some of the needs of buildings. This equipment may be around for 20, 30 years. What does that look like under different scenarios? Here in BC, 2 summers ago, we had a fairly severe heat dome that was way out of the normal design envelope of most equipment on the cooling side. So having the ability to model scenarios like that on real data, but not on sort of the traditional building model approach, which is a very physics-based, like I've got windows, I've got walls, but actually take a building performance data set collected under one scenario, shift it into a different climate scenario, is, I think, a very interesting application of machine learning and or AI that would get very much at the problem that I've been discussing. All
right. Niklas, how do you see it applying to resilience? I know Brad touched a little bit on that, but
I for sure believe that. I mean, we have to set the expectations in that. I mean, no machine learning, no AI is better than the data we're feeding it in with. And we still have, I mean, we're just making this transition as an organization, enterprise, to seeing data per se, big data, small data as kind of almost like something annoying that costs money to store, and all to really looking into it as an asset and keeping investing in collecting data on our system and our customers and using that. So first of all, we have to kind of get the right data in. You will be surprised how how limited data this region has on like a major problem such as congestion. We simply do not know. Whatever you read in the newspapers and all that, we have a very little data on how congested Metro Vancouver is, and so we are trying to remedy that by first putting out sensors, and then I think very quickly after that we have a pilot running, actually starting off on AI and cameras and trying to do vehicle counts and also I think on the back end a lot of automation can happen once we have the data. We're still very early days of collecting the relevant weather, passenger count, all that data into the system. And then I think a lot of the optimization for sure, it looks promising. We have one problem I can foresee where the routing software and routing decisions how to get people on the bus and train in the right time and reallocate vehicle doesn't optimizing that portion of customer experience does not necessarily mean that we optimize electric charging of these vehicles. So they're going to be two kind of management system at some extent competing. Well, hey, the bus should actually charge now. No, the bus should go and pick up passengers. So to optimize that kind of complex system and have the self-learning mechanism, see what actually works. I can see AI taking and also kind of like I said, video recognizing of course as anonymized as possible, but using video feeds to draw a lot of data can be a very cost-effective way of learning more about how this region works as for transportation with a strong AI in it. So we are looking into it, but it's really early days, and it always comes back to kind of garbage in, garbage out. If we don't have enough data or good data coming in, then no matter how good AI we have, we can only speculate. So yeah.
Awesome. Thank you so much, Niklas. So Jeremy, do you have thoughts on how AI could apply in the carbon embodiment you've mentioned?
I've had less success than Brad on the AI in buildings. We've tried out a few companies that have AI in their name for energy performance, and I think they're really hamsters behind it. So we're very strong believers in more data, more precise, more frequent data, and currently have engineers behind the scenes that, assisted through algorithms, but that's what we found to be effective to date. I'm sure that as it progresses, AI can help, but buildings are relatively complex systems, and AI is typically designed for very controlled environments without many feedback loops. And so I think AI has, and each building is different in its feedback loops and equipment and building automation systems. So not sure there on predicting like capacity loads, energy loads. I think there's probably more opportunity there. I think scrubbing utility grids for prices, predicted prices coming up, understanding what in the building can be turned down to anticipate those spikes, I think has a lot of opportunity.
Thank you so much. We do have one more question on the chat from Scott. It says, this one is for Jeremy and Niklas. How are you managing the access to capital for decarbonization efforts? Is the business case for these upgrades sufficient to obtain funding to make the project happen? This Niklas.
Niklas?
Yes.
Yeah, I can start if you want. Yeah, so I'm happy to say that the key investments we have to do, as I talked about a few, like replacing the current diesel fleet with battery electric buses and expanding our CNG bus fleet, as well as looking into more renewable gas and all that where we can, and also putting in charging infrastructure. We already have one, but we in Marpole, but then we have a few more, Port Coquitlam, Burnaby, others coming up. That's our province politicians have been very agreeable and see that we have to do this. So funding is available for a lot of the key investments. Now we have some incremental investments that are still unfunded for sure, including our non-revenue vehicles and also we are aiming towards a zero emissions next generation C bus for those of you who live here, our ferry, and West Coast Express as well, right? Who's running on diesel. So we have a few other, but I would say the bulk of our trip down to at least have a reduction is pretty well funded thanks to taxpayers and all that. And then what's going to be hard is going to be the last percentages. We may need to sequester or offset remaining GHG emissions from some stuff, refrigerants and waste and all that in the end to get really to net zero. But so far so good as for the big ones.
Perfect.
We've so far we've had great access to capital for energy efficiency projects that also happen to have carbon savings. But we've 30% reduction with an averaging a 3-year payback, so better returns than you would on buying and owning the real estate itself. That's shifting when you get to carbon reduction projects. Paybacks are more typically in the 10 to 20 years. And so you have to get a bit more creative with carbon pricing and what's the willingness of someone to if we were to sell the asset, who would buy it, and will they change the valuation based on those things? So becoming more challenging. We have some very large, $50 to $100 million decarbonization projects coming up. So I'll know within a year whether I got the capital or not.
Perfect. All right. Thank you so much. I think that was excellent. Any other questions? If you guys have any questions, I'll just maybe go around a few more clarifying questions with the team. And so, do you see any commonalities with the problems that articulated here? Have you seen any problems being solved in other industries, like based on the different 3 problems that both of you have, all of you have shared today? Do you see any commonalities within in both the problem in the resilience, as well as the carbon abandonment, as well as the building, the data analysis of building software problem that Brad mentioned? So this question is all for you. Brad, do you want to start? Do you see any similarities in all these 3?
I mean, I certainly there are. I think particularly between some of this, I think Jamie and I are both very focused on buildings, and so I can easier for me to draw the connections there. But it's data and information, and in his case, sort of a bit of a lack of good information when it comes to embodied carbon. And I would agree. I mean, I've encountered that same problem. It's hard to know where to focus without having a handy and sort of the experience that we have in other aspects of building operational carbon. I think we have a much better handle on. We know where to look to try to mitigate that, but I would agree with him that it's a little less clear with embodied carbon, and so similarly with my problem, it's sort of we've got some data, but we're a little further along. I think we've got good data on building performance, but it's sort of turning it into action. And again, I'd say there already are existing tools that use that data more in a building operations sense. And I'd say, though, that aspect of the market is much more mature. But there's been, I think, a real lack of adapting any of that data or tools, again, for the design community, and quite frankly, they haven't needed them until we've started to tackle this problem of heat pumps. Because the traditional engineer approach, you solve your problem by oversizing your equipment by 50%. That solves a lot of problems, but you can't afford to do that when you're electrifying. You can't afford the electrical capacity. You can't necessarily afford the equipment, which is, $1 million instead of $50,000, for example, for heat pumps versus boilers. So that's why it's becoming an issue for us now, because we, the existing practices for design are simply unsustainable when we're talking about decarbonization and electrification.
Can I just make a comment, Lou, to Brad? And Brad, like I said before, one of the aspects that you need to look into if you want to be able to improve operation in your boiler system is to increment that delta T operation that you have in there. That would allow you to not only to improve performance, but also maximize equipment utilization. That's one of the aspects that we have seen here in Calgary, for example. We currently testing the system at an ACO building in Edmonton, and we have done work with the University of Calgary and SAIT. And some of the result is you eliminate water mixing, increase heating equipment capacity, and that resolve most of the problems associated with performance in the building. And what is more important, CO2 emissions reduction. So, yeah.
Thank you.
And by the way, the answer is in the data. You look at the data, and the data can tell you right away how the system is running and how to perform it, even before you do any crunchy number on HVAC calculations. So, yeah.
Yeah. Okay. Niklas, do you see any commonalities in any of the problems stated here today?
Yeah, for sure. I mean, again, the access to high quality, perhaps as real time as possible data in order to have this kind of evidence-based decision making seem to be the same for Brad and Jamie as well. And we need to make that happen better. And then obviously, I mean, the whole anything energy efficient seems to be of interest to all, including heat pumps. Let's say again, we are behind on that, and both in our fleet and in all our buildings. So energy efficiency and big high quality data, 2 areas, I think.
Jeremy.
Yeah, I think another commonality is the needing to collaborate across peers. So, transit authorities sharing innovation, and I think same with buildings and engineering firms, is that there's a lot more appetite for collaboration to enable innovation, which is exciting.
Yeah. So one question I just have is, what role do you see regulations playing in either creating new markets or, apparently creating barriers to adoption to some of the technologies that might be coming out from the industries? Maybe Brad, you can start.
Sure. I mean, we're seeing a huge impact from regulation right now. I mean, City of Vancouver is phasing in a bylaw to regulate carbon emissions directly from buildings that had and fining buildings that don't meet the standard. And we've seen that to be very motivating for owners, especially the owners that haven't really been paying that much attention up until now, until the carbon footprint. I mean, there's certainly market leaders, and QuadReal is undoubtedly one of them, that have been on this carbon reduction pathway for some time. But there's a lot of buildings out there that really haven't done very much yet, and the idea of fines has been very focusing for them in that regard. And so we've seen a lot of uptake from that. I'd say there's also direct regulation of building the mechanical equipment efficiency in sort of the looking out into the 2030 horizon, where we may not be able to buy gas boilers in BC because all the equipment needs to have a coefficient performance greater than 1. So now we're looking at either electric or gas heat pumps kind of being the standard across the board. That's going to be a huge shift. And also, and actually something Niklas and I were kind of talking about earlier, and his being from Sweden, said I'm kind of jealous of some of the products they've had available to them for some time, and especially cold climate heat pumps that we simply don't have here because it's taken a while to get approval, and up until now the market hasn't been there. So we're starting to see more and more products, though. I mean, you can now have access to a fairly wide range of products from Japan and in Europe that we didn't have previously. That I think has been really helping to give us more options as designers. And yeah, I think there'll be more of that in years to come, but a lot of it is driven by regulation. And certainly add to that, carbon pricing and carbon tax. When you start to factor that into your retrofit business cases, often will make the business case much better, because if you look at what you will be paying, the avoided carbon tax can be quite significant, and enough to make a project that isn't otherwise attractive, quite attractive.
All right, Jamie.
Yeah, I think similarly, regulation is long. Smart regulation to drive appropriate action is long overdue, perhaps 20 years overdue, and so we're starting to see carbon taxes ramp up in the ways that they ought to, and performance-based regulations like the City of Vancouver ramping up the way they ought to. So we're supportive of increasing regulation that helps us on a net zero pathway, and we see that accelerating further and further.
Okay, awesome. Thank you. Niklas, how is regulation affecting the problems and the works that you're working on?
Yeah, I'm a bit out of my comfort zone there, and we have better experts here in the room, but I just joined from what we talked with Brad before, in that that's the example in Scandinavia and Sweden, where in the 90s, where we have very almost draconic at that time regulation for energy efficiency, and both carrot and stick, but also a lot of stick was got a lot of criticism from the industry, and we're not gonna compete, and we're gonna all go bankrupt. Then like 10-15 years later, they are like state of the art, and they're ahead of the game. So like hard regulation and transformative performance doesn't have to be, it could be a bit painful for the in the beginning, but we have to get it's a way to really, if it's done right, to get our industry up to standard with the rest of the world as well, and stay competitive internationally. So I think that's pretty important for our manufacturers and designers as well. So it's not all bad.
Awesome. Yeah, thank you. I think regulation is really critical in helping shape the innovation ecosystem in Canada, and I think there are some great innovations initiatives taking place, but thank you guys for that. So just wanted to ask, is there any strategies that you have employed in the past in engaging regulators? If anyone of you could share what strategies you have employed in engaging with key regulators to help advance your specific sectors.
I can make a comment there. So, I mean, in particular, we've sort of been, I guess, at the table for consultations with both, the province of BC and the city of Vancouver in particular, in developing some of the regulations. And this is an interesting sort of connection back to having that data available, is, from all of the energy audits and work that we've done over the last 10 or 15 years. We were able to provide really great feedback to the city of Vancouver as to how they should set those targets. And I think at one point we were advocating that they be more ambitious, and that was achievable compared to some of the targets I think they had initially looked at. And they took some of that feedback, and I think it helped strengthen the regulations and make them more aggressive and more effective, quite frankly, than they otherwise would have been. But we were only able to do that because of the experience we had in the built environment and working through existing buildings and doing audits and seeing what was possible. So I think that kind of feedback to regulators is really valuable. And that, I'm sort of a member of a technical advisory committee for the city of Vancouver as to how we roll out and implement these regulations and help build owners achieve them. So I think they really benefit from the feedback from those of us who have, and I'm sure, again, in the building sector, some of the projects and experience that QuadReal has from their past projects would be information that's really valuable to the regulators. And because it helps show them what's possible. And then if we want to bring the rest of the market along, then that's the sort of information that they need.
Thank you. Niklas?
Yeah, I mean, being from the innovation side, mostly I'm interacting with the lawmakers is true. And I think that's important here as well to make them aware that some of our laws are outdated, and to work with kind of a regulatory sandbox approach, allowing for innovation happening for at least some period of time, and trying out, allowing new things can be quite powerful, for sure. And yeah, I guess that's the extent I can influence that. But of course, we are consulted sometimes when we get the chance from the province and others on regulation and new laws. But mostly we kind of have to work with what we get. I would add one. Yeah, I can stop there. I have another area being procurement, which actually I think we haven't talked so much about here, but I think that's an important thing I can address a bit later if you want, Ali.
All right, thank you. Jamie?
I think just to echo what's been said, I think performance-based regulation that good regulations has a long lead time, shows you where you're trying to get to, is coordinated with other major markets. So if California is doing it, Europe's doing it, then there's enough market size for innovation to flourish. So I think those are the key things. And then to also turn off the taps for subsidies for antiquated processes and technologies. So you're not increasing costs all the time. You have to stop subsidizing certain things. So I think when we see that package of regulations, we see a lot of movement. We're supportive of those.
Thank you. So the next one I just wanted to add is, what advice do you have for researchers, for instance, in the audience, on how best to engage with stakeholders and ensure that their paths align with the challenging problems, the urgent problems that they're trying to solve?
Do we have any researchers in the room?
Yeah.
I mean, I can see, again, that's my limited experience. I think we are underestimating the innovation going on in the academic sector. In the research, we often have to admit that. That's why I asked professors seem to be seen as hard to work with, and they are egoistic and they're doing their own thing and all that. But we launched quite early in my team an academic outreach program called the New Mobility Lab. If you have any academic researchers here giving out grants, funding research, and I think we have a very positive experience. We have funded some 60 researchers throughout the last years, and we have been able to fill in the gaps between like large research funding agencies and not having our own R&D really. Sadly, in Translink, we are relying on external. I think the academic sector is very interesting to work with in this area. So we have an open window, and if not the door, at least the window to engage with the academic sector more. We are welcoming now.
All right, thank you, Niklas. Brad?
I don't have a lot more to add to that. I think the important thing for researchers is to benefit from the real world experience. We've kind of heard it come up a couple of times. I mean, when you're designing and testing equipment, what you see in the lab may not mimic what's in the field. And I think it's important to understand. And we see, even aside from the research community, we see the same thing with designers who specialize in new construction. They don't have a lot of experience necessarily with the operations side of buildings. And critical mistakes are made because of that. And so I think it's, again, with the building sector, I mean, buildings spend most of their life in an operations phase. I mean, you kind of build them and then, they're there for the next 100 years. And so that's in my field, that's sort of an underappreciated aspect of it. And I think sort of everyone from researchers on down would benefit from having a greater understanding of the needs of operators and the operations folks who are, because still today, most of the carbon that's emitted from buildings is emitted over the life of the operations. I think that's going to shift more towards the embodied carbon piece as we decarbonize, but we're not quite there yet. So I think we still have this very important operational carbon piece to tackle. And I think actually listening to the people that need to operate the buildings, and not just the engineers, the operators and the folks who are in that building every day and know it the best and understand how you need to satisfy tenants, but also not use too much natural gas, and the balance between those things that can be very challenging is, I think, something that everyone would benefit from hearing directly.
All right.
I think to build on that, my piece of advice on energy and carbon stuff is to if you have an idea or technology, is to get the utility companies on side. My first question when someone says, I've got this thing that saves natural gas or electricity is, has BC Hydro or Fortis signed off on it? Have they given incentives, or will they give incentives on this? Or will they run a pilot? And if the answer is no, then we're not likely to continue the conversation. They've got people who sort of do this all day and night, and we're sometimes happy to go first if we've got Fortis lined up or BC Hydro lined up. If not, we will go third. We'll be the fastest to adopt the technology third, after two other pension-backed real estate companies.
All right. Yes. So thank you everyone for this session. We're supposed to have a breakout sessions, but because we didn't have a lot of members right now, we will stay on this main room. So if you have any question, I think one of the things that we can do also open up to see who is on the room and just maybe get a little bit of round of introduction, some of the participants, get to know what projects you're working on, just to have that engagement and with the speakers as well.
Just unmute myself there. Hello, everybody. Well, I've worn a few different hats over the last couple of decades of my professional life. I am trained as an architect, has worked as one for over 20 years. Lead accredited professional, worked in over a dozen lead gold and platinum and silver buildings. Last 10 years, been focusing more on entrepreneurship in the sport entertainment space with a tech and sustainability overlay. And coming very soon, I am going to be joining the Foresight team in a capacity I can't quite mention quite yet, but it's all connected with all this good stuff with construction tech, materiality, and I'm excited to be here and look forward to having many conversations with everyone that's on this call here today and beyond.
You can go. Yeah, Drake.
Hello. Sure. Yeah. We make a photovoltaic siding product, or a BIPV siding product for buildings that are maybe the roof area is a little compromised, and you need to have some vertical photovoltaic source of energy to make the building net zero. Our sweet spot is kind of like a row home or some kind of low-rise MURB where you have some roof space, but you need to utilize some of the wall space as well to achieve net zero.
All right, thank you. Robin Sim.
Oh yeah, no, I just stumbled across Foresight and meeting people just hiking, and been interested in the clean tech sector and been looking at companies like Intelligent City that have been doing a lot of more manufacturing related clean tech. Definitely appreciate Brad's insight on connecting with people on the operations. I used to work at Honda, and when you talk to the people who maintain the facility, you learn a lot about the struggles between, the existing systems and retrofitting new ones into, current plans that they already have, and striking that balance between a pilot program and working with, existing HVAC systems that are, 25, 30 years old, and finding a justification case that really works with the whole team. So yeah, it's not always, the best technology wins. It's a compromise between, what do we have in our existing capital and how can we justify that return on investment over, a Honda was 3 years, right? If you can't justify 3 years, it didn't go. But yeah, it's just interesting to hear that insight.
All right.
Just here for the information.
All right, thank you so much. Kelly
Mercenary with Pannaboat International. So we do a Western Red Cedar log home package and commercial structures as well. So low embodied carbon with that. Always a struggle on the energy efficiency side as well, because they always look at the R value of your log wall. A lot of the conversation working with government and WELL's incentive has been quite interesting today. Was previously on a unique building types committee with the BC Housing and their Building Safety Standards branch, looking at codes of some of the recent changes that just took effect May 1st related to log structures. So it's been really kind of interesting sort of seeing behind the scenes of how code gets changed. And they are thinking about embodied carbon, but just not quite yet. It seems like. Yeah, so here was part of the Build Next program, which is how we got connected with Foresight. So here to learn and connect and see what we can do with using more forestry products. Thanks.
All right. Thank you so much, Kelly. Scott?
Hi, I'm Scott Sinclair. I'm actually with SES as well. I work with Brad, and I have a different role in SES as the mechanical design service manager. I'm also the CEO, and we've been focusing a lot on different kinds of deep energy retrofit projects, where we take existing buildings and we transform them with a target of 80% GHG reduction or more. And so we're doing that on multi-unit residential buildings. We've just successfully created a vision for Science World to have basically a full electrification of all of their systems. And but I think also taking into account climate adaptation is a big part of what we're doing these days, trying to add cooling to buildings that don't have cooling and increase the capacity of cooling for buildings that do, because the heating loads we're seeing in buildings now are far greater than they were when they were designed 20 years ago. So I think heat pumps are my world, and I think I'm also really involved in the Building Electrification Coalition in BC, and trying to make sure that we collaborate with different levels of government and different consulting and industry partners to promote decarbonization through electrification. And overcome some of the barriers and challenges that exist for that activity. So it's really great to see the conversation happening here, and happy to hear everybody's perspective.
All right, thank you so much. Caroline?
Hi, I'm Carolyn Moss. I'm an architect. I've been working on high performance and low energy homes for about 25 years, and realized 2 years ago, well, before that really, but I started to do something about it about 2 years ago, created a startup called Homes to Zero, where we're looking to really simplify the process of how we can get homeowners to get their home to net zero quicker and faster. A lot of challenges with the current programs from NRCan, et cetera, and this whole conversation about actual energy use versus modeling energy use. For anyone who's used Hot 2000, you know the pain that we've gone through. So I'm also chair of the Net Zero Architects Network that we created in Ontario. It's usually a group of competitors that we all just came together and we're like, let's just talk about all these projects we've done over the past long time and what lessons learned and how we can, again, just ramp things up so we can get more houses retrofit faster. So I've been part of the Foresight Launch and Deliver program, moving into the residency portion.
All right, thank you. Have from Bill Smart. Yeah.
Hey everyone. Yeah, my name is Harv. I'm the founder and CEO of a company called Build Smarter. What we essentially do is use 3D modeling and CNC machines to build homes out of recycled steel, all-in panels, all your floors, all your joists, all your trusses. Everything is prefabricated off-site, built to sent to your job site, installed really efficiently.
All right, thank you so much, Ryan.
Hi everyone. I'm Ryan Gregory. I'm an engineer and product manager at Miru Smart Technologies. We're a Vancouver-based startup, and we're developing electrochromic glazing, sort of tintable smart glass for buildings and vehicles. So our focus is on reducing heating and cooling loads for the built environment, as well as improving occupant comfort.
All right. Thank you, Alexandra. Okay, looks like Dylan. Next on my screen.
Yeah, just here out of general interest in the space of building and built environment decarbonization. Follow a couple different organizations that are focused on this. ZebX has a lot of good resources, and just saw that this was being put on by Foresight as well. So wanted to tune in to just learn more.
Thank you, thank you. Darren, I know we heard from you, but maybe you can just give an intro yourself.
Darren, is that?
Yes.
Oh, okay. So yeah, as I said before, I'm the founder and president of the BBS technology, and we basically develop a technology that eliminate one of the major problems that the HVAC systems have nowadays. Of course, the problem is not commonly recognized, and that's have to do with what we call water mixing. That's the basically our focus. And I need to suggest that no matter what type of retrofit you are considering or have it in mind, it's going to work for sure, and it's going to improve somehow efficiencies in the building and greenhouse emission performance, but not in the way that you would expect it. And reason being is, no matter what you do on the envelope, if you don't really look deep into what make the system highly efficient, you're never going to resolve that efficiency problem. We have experience with buildings here with the University of Calgary and quite a few other buildings here in the city, where they are packed with a high efficiency everything, from condensing boilers to BMS to distribution and chiller equipment, and they still performing at a 65, 67, at best 70% energy efficiency performance, and the main reason, mixing operation. So that's the message that I want to leave everybody with. No matter what you do, if you don't fix this problem, you just basically putting a little bit of hot water here, there, and there to resolve a problem that is not resolvable. So yeah.
All right.
So thank you.
Yeah, no, thank you very much for all the audience that were around today. I just wanted to give it back to the panelists to maybe share any last word that they have, or points that they want to talk about the problems, and then we'll have a poll from Nisa, and then we'll wrap up in the next couple of minutes. Brad, anything?
I don't have too much additional to add beyond what I've already said, but I think one thing that I constantly sort of have some existential dread about, I mean, aside from climate change, but is the enormity of the challenge. There's, and again, focus mostly on the building sector, and obviously there are other aspects to emissions reduction, but even in the building sector, I mean, there's a lot of buildings out there, and we need to expand our capacity kind of throughout the industry, from engineers, contractors, operators, kind of all the way up and down the market. Probably need 10 times the number of people that we have, or we need to find a way for the existing people to be much more productive and effective in executing these products, and probably a bit of both, right? And so really, one of the things that SES that we focus on is, I mean, again, as a small company, there's only so many projects that we can take on. But what we can do is share our experience with the rest of the community. There are a lot of engineers out there. A lot of them don't have that much experience with low carbon retrofits, electrification, heat pump design. So, and I think we just heard this from one of the participants, getting together with the competition, just sharing that knowledge is so important, because quite frankly, there's lots of work out there for all of us. There's no shortage of projects to do and challenges to tackle. That I think that's something we can all benefit more from across the board, is just that sharing of knowledge and sort of trying to lift all of us up with that shared experience, so that we can be better and more effective at pulling off these projects. So that's just a message that I kind of want to get out there for all of us, is I think we'll accomplish more working together, and that's a real mission of ours, is to share both the good and the bad. I mean, we've had projects that have gone really well, and we've had projects that haven't been as successful. And I think sharing both of those lessons is really valuable. And it might even be more valuable to share, hey, this thing didn't work, don't try this, or here's what you should do instead. And so, yeah, I think across the board, just more of that will help us meet the challenge in front of us.
All right. Thank you so much, Brad. Niklas?
Yeah, really inspiring conversation, and I agree. Like it's easily to be overwhelmed with the challenges ahead. I guess the way to do it, especially for me working in a big semi-government bureaucracy, is to try anything we can to make us more agile and more responsive to ideas from outside. I guess one message out to you guys: don't be scared or worried to contact us and pitch in your ideas and all that. Also outside this, we are open to hearing. We are cumbersome to work with, and everything is slow and bureaucratic and all that, but once in a while we get it right and really can fund and demonstration program and all that, and getting better and better. We have two channels. We have the one agreement with Vancouver Economic Commission. You can check out Project Greenlight. We're actually really targeting kind of low investment but still interesting demonstration projects. We can try to use that channel to work something out. And then we have our big yearly open innovation call. You're happy to check out too, and submit stuff depending on the topic. So we are open for business, and yeah, looking forward to hearing from more of you.
All right. Thank you so much, Niklas. Jamie?
Yeah, I think just leave on note of optimism. I think there's a lot of innovation, a lot more innovation is needed. And I think people are far more receptive to it now than ever. So I think it's a great time to be an innovator and to be an entrepreneur.
All right. Thank you so much.
So here are our upcoming sessions. The next one is on June 7th. And we have our investor readiness workshop. The deadline to apply is May 26th. I'll post the link in the chat here. That's about it. Any final words to say, Aliu? If not, I think we're ready to wrap up.
Okay. Thank you so much for our amazing speakers today, for being very engaging as well. It was really a pleasure getting to moderate the session. I am Aliu Jal, the Director of Sector Innovation at Foresight. and I was moderating this. So basically, each of the subsequent session, the one we're having is under the WaterNext team as well, the one we're having in June. So we will be having another session on the water discussion around problems within the water sector. And if you're interested in some of those, please sign up, and we look forward to seeing you on the next session. On behalf of Foresight and the entire team, we want to say thank you very much. Merci beaucoup.